The domain. Well, we know the domain, the denominator, can't be 0, which means that x squared minus x minus 6 can't be 0. This is x minus 3, x plus 2 can't be 0, x can't be 3, x can't be negative 2. So it's all real numbers except for negative 2 and positive 3. The VAs will be x equal negative 2 and x equal positive 3. This guy has 2 VAs. By the way, these graphs are very predictable as well. More complicated, but very predictable. Let me make a note of it because it's going to be helpful to me. What is the multiplicity on these VAs? The multiplicity what? 1. And that says on either side of the VAs, the arrows go in opposite directions. The arrows go in opposite directions on either side of the VA. That makes our work a lot easier. End behavior, well, the end behavior model is 6 over x squared. Well, there's nothing to reduce, but as x goes to infinity, 6 over x squared goes to where? 0. So I have a horizontal, and it is y equals 0. So let's put in what we have. We have 2 VAs. X equal negative 2, x equal positive 3. We have 1 HA, y equals 0. Now, what's so predictable about these graphs is that, except for the inside, the outside looks like 1 VA, 1 HA. In other words, they're either going to be across from each other or they're going to be kitty corner from each other. The inside is either a parabola or it's an S. Now remember, graphs can cross the HA, so it can cross this guy right here. But it can cross the HA. So let's go after the x-intercepts and see what information it gives us. The x-intercepts will be where the numerator equals 0. Well, that didn't help. That's none. Which gives me a piece of information right there. And you're going to say, why? Because that says the graph never crosses the x-axis ever. So if the graph is completely above or completely below, that means this can't be an S in the middle. If it were to be an S in the middle, it'd have to cross. That means it's a U in the middle. Just a U, that's the nature of the creature. Y-intercept, well, that's where x equals 0. So you have 6 over 0 squared minus 0 minus 6, which is 6 over minus 6 or minus 1. So it's 0 minus 1. Oh, big whoop. I have 1 point. That gives me nothing, except I do know where the U is. The U is here. Non-S is U. Now what am I going to have to do? I have to find out where the stupid graph is on the outside. So now I'm going to need a T-bar chart. And I look at my graph and I said I need to know where is it on the left-hand side, so I'm going to pick an x value of negative 3. Now what's that going to do? If my coordinate point is up here, then the graph is in that quadrant. If my coordinate point is here, then the graph is in that quadrant, because remember it looks just like the 1VA, 1HA. Well, I also then need a coordinate point on the other side, and I'm going to pick 4. And that'll tell me where the graph is, here or here. And if I'd like to have a better looking U shape, I can pick -1 and 1. And then I just fill in my T-bar chart. So, if x equals -3, then what's y? Well, it's 6 over -3 squared minus a -3 minus 6 was a 6 over 9 plus 3 minus 6, which is 6 over 12 minus 6 is 6, which is 1. If x is 4, I'll have 6 over 4 squared minus 4 minus 6, which is 6 over 16 minus 4 minus 6, which is 6 over 6 divided by, this is going to be 6, which is 1. If x equals -1, then I'll have 6 over -1 squared minus a -1 minus 6, which is 6 over 1 plus 1 minus 6, which is 6 over minus 4, which is minus 3/2. And if x equals 1, I'll have 6 over 1 squared minus 1 minus 6, which is 6 over minus 5, which is minus 1 1/5, minus 6/5. Now this gives me the information I need now in order to do this graph. If x equals -3, y equals 1, that tells me that the graph is here. And if x equals 4, y equals 1, that tells me the graph is on this side. And if x equals -1, y equals -1 1/2. And if x equals +1, y is -1 1/5. And here's your parabola. So that's what he looks like. Now, what I know is this. I didn't have to do these 2 inside points if I didn't want to. And why is that? Once I knew the graph was here, my asymptote is multiplicity 1. That means if this arrow goes up, this one goes down. Here, once I have this point, that says this is where that graph is. If this one goes up, because I'm dealing with multiplicity 1, the other side goes down. But if in doubt, what I did was I picked points that would give me that shape out. Yes?
Your math is wrong on that last one. It should be 6 over -6.
Oh, okay. I'll take it. I like that number better. And that puts this point now, right there. So that's what he's going to look like. But they're very predictable. On the outside, they're going to look like 1 VA, 1 HA. And on the inside, they're going to be a parabola or an S. Very predictable. Very predictable. They're the more detailed of the graphs, clearly.